Alright. Let's continue. Okay, let me pull up the table of content first. Okay, if I remember correctly, we are in this section. Let me put that up. Okay. We already done this. v1.sing. Okay. The wait system call. I didn't this too. We already done p3.c, which is exec, if I remember correctly. Right, the exec system call. And now we are in this section. And previously, I'm kind of confused, right? Unix system start looking for free file descriptor at 0. And then why, in this case, right, we are using standard output instead of using standard input. So, okay, let me check the open main page. Okay. Oh, wait. Where is it? Okay, I think this one. The file descriptor written by a successful call will be the lowest number file descriptor not currently open for the process. So when we start a process, do we only create the file descriptor, or we also open the file descriptor? Yeah, that is something that I'm not sure yet. Again, why we assign standard output with the open system call? I mean, if we take a look in here, I think it was something like this. SafeFT, right? S2. Do we create this or also open this? I mean, from cell, right? I assume the standard input or F file descriptor 0 is, what is it called? Is occupied to, what is it? To receive, maybe that's the word. Okay. To receive the input, again already occupied, now we didn't use standard input, and then the next thing is that standard output ft1 file descriptor 1 tail 3, and then there is also standard error, right? It's something like this. So when we spawn a cell, the cell immediately occupied the standard input. So the standard input is no longer free, even though Unix system start looking for free file descriptor at 0. And then when we use open, the first, what is it called? The first standard stream that is available is standard output. Is that it? Maybe. Subsequence write by the chat process to the standard output file descriptor. For example, by routines such as printf, and then we route transparently to the newly opened file instead of the screen. Okay, this kind of make me wonder. Like when we start a cell, do we only create the file descriptor, or just open the file descriptor immediately? Equivalent to calling open. Call to say okay. Right, only. And again, let me check self-ft game pts0. Interesting. Yes, pts0. Okay, let me check Tmax P3. Okay. I think P4. will become open across the exec system call. Okay. Alright. When a process is started, part of the work the operating system performs is to create the data structure that manages the process file descriptor, and in common sense populate descriptor 0, 1, and 2 with the pointers to its controlling terminal device. Some processes are launched with this file descriptor link on different device than the terminal. The process have one more of this file descriptor. Okay. The process file descriptor. Maybe we can explain this. Open across the exec system call because file descriptor is attached to the process instead attached to the process instead of the program. So even though we replace the program instruction in the child process, let's do this. The file descriptor, we are still using the same file descriptor. We are still using the same file descriptor. So even though we replace the program instruction in the child process, we are still using the same file descriptor. That makes me wonder, are we really closing the standard output file descriptor and not just open the file.txt? Open the file.txt here. I am still not sure. Maybe okay, something like this. I mean, okay, let's bind the chat process to the standard output file descriptor. For example, by routine such as printf, okay, will then be route transparently to the newly opened file instead of the screen. The interesting tidbits about this output, okay. First, when P4 is run, it looks as if nothing has happened. The cell just prints the comment prompt and is immediately ready for your next comment. However, that is not the case. The program before did indeed call fork to create a new child process, and then run the WC program via a call to execvp system call. You don't see any output print to the screen because it has been redirected to the file before the output. This one. Second, you can see that when we get the output file, all the expected output from running WC is found. Cool, right? I mean, where is it? If we note this, right? This printf is not in the output file. Let's check that out. Thing like this, right? File.txt, and then let's check. Okay. See, this one is not in the file. Instead from this. It is interesting. Now if I do this, then I can delete this first and then, what is it called? Like appending, instead of replacing. Is there append system call? Nothing, okay. Let's see. Okay, it's still the same. We didn't print out this one. It is interesting. But we print out this one, right? And oh, I just noticed that we also print out the start. This one. Okay. But why is it not at the first line? Instead we are printing out the output of the, what is it called? The WC comment, It's similar to something like this, right? So, what happened there? And it's also the same when we are using the greater sign instead of double greater sign. Okay, I still have no idea. Unique pipes are implemented in a similar way, but with the pipe system call okay, there is pipe system call. Well, at least we also have the POSIX standard for it. What about the 7? I haven't seen the main page 7. Miscellaneous information manual from the Linux main page. Okay, interesting. I think okay. The system call, right? In this case, the output of one process is connected to an in-kernel pipe. Okay. And the input of another process is connected to that same pipe. Okay. The output, right? The output of previous process is connected to the pipe and then become the input of the next process. Thus, the output of one process seamlessly is used as input to the next, right? Input to the next. And long and useful chains of commands can be strung together. A simple example is something like this. We use ls, right? And then grep, let's say chapter. Here it is, the result. So the output from ls become the input of grep, something like that. As a simple example, consider looking forward in a file and then counting how many times that word occurs with pipes and the utilities grep and wc. It is easy. Just step this one, okay? What is this? Let me check. Only matching. Only the match non-empty part of matching line with its such part on spared output line. Okay. So this is the pattern, this is the file, and then we are using the output from grep, right, as the input from wc. Okay, into the command prompt and marvel the result. Finally, while we just have sketched out the process API at a high level, there is a lot more detail about these calls out there to be learned and digest. We'll learn more, for example, about file descriptor when we talk about file system. Okay. So we will talk about the file descriptor in the third piece or third part. Okay, for now suffice it to say that the fork or exact combination is a powerful way to create and manipulate processes. Alright. Okay, let me... Yeah, again, I'm kind of curious though. Do we really close the standard out file descriptor, or we just directly open the file.txt without really opening the standard out file descriptor? I am not sure. I mean, if I understand correctly, where is the printf? See, the printf and fprintf read output to the standard output. So in a way, wait a minute. Maybe we only print out the, what is it called? The result of WC command because of exact. Maybe like we are discarding the printf and just capture this one. Currently I'm still not sure. And why the parent output is after the child output, start should be at the top, right? If we run this something like this, right? Start and then child, and then the output of the WC command, right? Similar to this one, and then the last print, which is this one, parent of the PID of the chat process and so on. So why the order is different when we are using redirection? I am not sure. Why standard out is the first available file descriptor and not standard in? Yeah, I'm still still not sure about that. Maybe we will find out why the standard output is being used with open instead of the file descriptor 0. Again, my hypothesis is that what is it called? STT-in already occupied, right? Occupied when spawning cell, and the what is it called? Kind of forgot. And the lowest number here. And the lowest number file descriptor is lowest number descriptor is stt out. That why? Let me why open using out descriptor by default, maybe something like this. Can that is what I understand from this statement. Will be the first one available and thus get assigned when open is called. Is it because STT-in already open? Maybe that's the case. Again, I'm still kind of curious. Do we really close the standard output or not opening the standard output at all and just opening the file instead? I mean, there is some, what is it called? Some subtle difference, I guess. Is it because occupied and not available anymore? Is that it? Yeah, what is free file descriptor means? And lowest descriptor after is STT out. It's even not occupied yet. maybe, again, proc self ft like this. Maybe when we start the process, we are only create this file descriptor but have not opened it yet. Maybe. I'm still not sure. So when we, what is it called? Oh, but for shell, right? For shell, maybe we immediately open the standard input file descriptor. So maybe the term is not really occupied but open. Maybe that's the word. Yeah, I'm not sure what the term is. Open. Open it yet. But yeah, what happened when the process did not take, oh, wait a minute, no, not that one. Okay, see the different process here. I think this is the file descriptor of the ls, and that make me interested. Maybe we can do something like this. Yeah, how do we know that the file descriptor is open? In case anyone didn't know, if I remember correctly, $sign means that we print out the process ID of the current process, something like that, if I remember correctly. Okay. That has not opened yet. Maybe something like this. Is it because stdin already open and the lowest number file descriptor that has not opened yet after stdin is stdout? Maybe. I'm still not sure. Anyway, let's continue to this, right? Oh, we're immediately using the fork. Okay, stdlib. Do we need stdlib? I am not sure. And let's just see how it goes. In std string, do we have the string? Oh, this one. I think I'm not gonna use this one and just use. I want to try out. Can we use, what is it called? Can we use the array of character instead? We will see. I mean, if you are using str tab to duplicate the string, we need to free the memory. Okay. fcntl. What is this? Oh, I mean, maybe we need to use stdlib because of exit in here, but I think I will use return instead because we are in the main function already. fcntl. Let's see, excluding this one to find out which function that we need, which function that need this library, I guess. This header file. Says start.h, okay, and then we start. Is it because of this? Let me check. Oh, okay, we use this for open. Then what are we using this for? Interesting. Okay, fcntl, okay. Void return 0, okay. Fork if rc less than 0, This make me curious though. Can we replace this with, what is it called? We the file descriptor number, like 2 or maybe 1. Maybe let's try that out later on. Return 1. Okay. Redirect standard output to a file. Oh, okay. It was maybe the standard output open during the parent process, right? Maybe. We can check that out later on. Else if x equals 0, a file. Wait on it. Okay, this. Oh, wait a minute. Create right. A call to create is equivalent to calling open with this flag. O underscore create underscore WR only and O underscore zoom. Which is this one? So it's like we're calling create function. But then again, if the file ID access and is a regular file and the access mode allows writing, it will be to get to length 0. Oh. If the file is of first in, first out or terminal device file, the O underscore drum flag is ignored. Otherwise, the effect is drum. The effect of drum is unspecified. Okay, so maybe this is the reason we are replacing the, what is it called? The previous content. We are to get the content to length 0. Maybe. Okay, I'm still figuring things out. Currently, let me check in here. See, this is from STD.io, right? Instant file. Close. Wait a minute. STD out file now. File now. let me try to compile that. Chapter V4. Okay, and then it compiled. Let's try using this one. Can we do that? Can we compile that? No. We cannot compile that. Okay. Passing argument 1 of makes pointer from integer without a case. Alright. It is a pointer. So yeah, we cannot do that. Which means we also cannot do this, right? Right, almost similar to this one. Okay. But with close, is an integer. The parameter of close is the integer. Alright. Okay. Open this one. Okay, top path and then flag and then mode. Path, flag, and then mode. I think it is the mode of the, what is it called? The file. For example, something like this. If I understand correctly. Okay. The path, okay. Before txt, let's call it that. And then using this flag, maybe later on we will try excluding this one and see what happens. Great. Write only. So, okay. And then XU, something like this. Can we compile that? I forgot to change that. Okay, at least we can compile that. What about this one? Like, is adding space have some effect or not? Okay, it's still compile. We can compile this. Alright. Okay. And yeah, what happened if we didn't close the standard output, you know? Well, let's find out. Close. Yeah, that made me curious. Is close gonna have an error? An error -1 is written. Okay. So we can get an error. If n equal -1, what should we do? Should we print out? And no is set to indicate the error. Okay, maybe we can try using this one. Alright. Yeah, I kind of forgot. Oh no. Well, I don't think that is that important. Close error, something like this. And then where is it? Oh, entry. Section 3. Return value. Okay. And then what about the open? Return value. Unsukses open add and create return the new file descriptor a non-negative integer. On error -1 is written. Okay, maybe we can do something like this. Alright. If error equal different error open error okay constant cmd right for the command. What is it called? WC. And then for the argument, previously we are using, what is it called? we are using the string literal directly, and now I want to try out using the array. The array of character instead. Okay. Let me check. Okay, argv. I'll be calling it something like this. And then cons args. We initialize this, right? Cause null at the end, and then GMT, and also the args. Okay. Discard cons qualifier from pointer target type. Okay. And if we remove this one, it looks fine. I think red string. Okay. Discard cons qualifier. Now what next? Let's use string of character instead. Okay. And then using execvp. Execvp. Okay, you know what? Maybe let's do this instead. Okay, right. No, we remove this one. Of course, cons, right? CMT and args. Discard cons qualifier. Discard cons qualifier. Okay, so kind of forgot about that. Let's do this instead then. CMT and then args. If I remember correctly, the argument needs to be null terminated. The array of pointer must be terminated by non-pointer. Oh, with non. Okay. And then L equal -1. Error. Save error. Okay. Let it compile at least. Else wait. And this kind of make me curious. What happened when we use printf after we close the standard output? Let's find out. Okay. Let me check. Wait, what? Why is it? Wait a minute. Okay. Is it because of this one? Hold on a minute, let me check. An empty file. Okay, it is empty. So why is it hanging? Is it because of the printf? Unused variable, okay. Oh, maybe because of this. Right, what is going on? Let me check. Okay, right. Empty. Or maybe don't need to use this. Just ugly, but yeah, what? Why is it so slow? Oh, and the color, okay. And open, not full. Oh, okay. Has like what is it? Has read and write only, no executable. Maybe we can do something like this. 6, 4, 4, maybe something like this. Okay. Yeah, why is it so slow? What is going on? Okay, let me check. We are not writing anything, huh? Interesting again. Right. What is going on in here? Is it because of this? Really? Chapter 5. Again, what is going on? I am still not sure. Or maybe we should use this. Wait, no. Then would be ID. I mean, like, read any type process. Okay, I am still not sure what's going on. Let me add a tutu. I assume it is on this one. The problem is let me add tutu. Debug why the process hang. Okay, so I think we will try debugging this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.